how the consideration of motion of a single nuclei, single nucleon, say proton or neutron, inside a simple harmonic oscillator potential. The potential has been taken as simple harmonic oscillator potential. Now you need to understand one point, that the simple harmonic oscillator potential is, this potential has been created due to the interaction of all the nucleons inside the nucleus. And when we are considering the motion of a single nucleon, say a single proton or a single neutron, then we assume that this single neutron or the single proton is supposed to be acted upon by the resultant force, attractive force or repulsive force. Here it is attractive force, nuclear force, acted upon by the attractive force, so that it is moving in a harmonic oscillator potential. And in Schrodinger equation for a single nucleon, we have separated the radial and angular parts of it. Since the potential is spherically symmetric, we considered only the radial part. Now, after considering the radial part, um, we have seen that the equation, the second order linear differential equation, and to have a physically acceptable solution, or to have a meaningful solution, some conditions has to be imposed on the equation. Some condition has to be imposed on the equation such that there is a meaningful solution. If that condition has to be imposed and has been imposed, then we have seen that the energy of the nucleon is basically quantized, and the energy values are governed by three quantum numbers. One is alpha, and which is associated with n principal quantum number, and L orbital quantum number. The total energy in that case was obviously related to alpha values, and for each alpha values we have different n and L values, and based on this, and for each the energy value is basically determined by alpha values, and n values, um, alpha values and n values, and n values and L values actually determine the number of nucleons. For example, for any L value, the number of nucleon will be 2 into 2L plus 1, because for each L value there will be 2L plus 1 minus L, 2 plus L, this number of magnetic quantum numbers, ml values, and for each ml values there will be 2 spin quantum numbers, spin values plus half or minus half. So for each L value there will be 2 into 2L plus 1 number of nucleons. Based on this, we have calculated the number of nucleons in each cell, and in each energy level, and then summing up the each energy level, we form the closed cell structure, and we have counted the cell closure number of nucleons in a cell closure, and we have seen that that the first three numbers 2, 8, 20 agrees well, cell closure number agrees well with the magic number, but the other cell closure number, say 40, 70, 112, 168, 240, these numbers are not the magic numbers. So there was a discrepancy in this model. In order to address this discrepancy, the spin orbit coupling term was introduced. What is this? You can understand the nucleons are moving inside the potential, inside the nucleus. So it has orbital angular momentum, as well as it has it has intrinsic spin, so it has spin angular momentum. Now these two angular momentums will be added up vectorially to give total angular momentum J, and the coupling of this spin and orbit angular momentum interaction follows some quantum rules, and this will be determined by the potential spin orbit coupling potential uh, of suitable form. Now the spin orbit force is not central. It is because spin has not has discrete values plus half or minus half. There is no other value. So spin is discrete. So also L values are discrete. It should have integral values. So the potential spin orbit interaction potential should be non-central in nature. So we consider now the spin orbit interaction term, which is VLS equal to minus phi r L dot of S. The L dot of S term, phi r is the potential, which can be taken of the form d by r del S del r, where S is a spherically symmetric function, and this L dot of S couples spin and orbit. Now total angular momentum as usual will be J equal to L plus S, and since S have two values plus half or minus half, so the values of J will be J will be equal to L plus half or L minus half. And now due to the spin orbit interaction, for these two J values, the mean value of the potential VLS would be different. How can we calculate this thing? Let us see it little bit, not in detail, little bit. To calculate the expectation value of VLS, we have to first calculate L dot of S. Now L dot of S has this form half second bracket J into J plus 1 minus L into L plus 1 minus S into S plus 1. This is the form. You have already seen these type of forms in your atomic physics classes, where spin orbit of the electrons were considered. You will also see it in the later classes. In this class, when I will consider the magnetic moment of the nucleus, for the time being, you can consider that L dot of S has this value. J dot of S, S dot of L, these have this form. And if we put L dot of S for the two different values of L, means J equals to L plus half and J equal to L minus half. In the equation, in the L dot of S equation, we put this equation, then the expression for VLS, average value of VLS, would come out to be minus L by 2 phi r, average value of phi r, for J equal to L plus half, and equals to L plus 1 whole by whole 2 average value of phi r for J equal to L minus half. Now you can see that for two different values of J equal to L plus half and J equal to L minus half, these values are different, and the value expectation value of the potential for J equal to L minus half is greater than the expectation value for J equal to L plus half. Now the difference in the energy levels, if you calculate, then it will come out to be L plus half average over phi r, which is definitely positive, implying that J L minus half is energy is higher than the energy J L plus half. You can see from the expression also. Now the observed spacing, that means experimental fact, an experimental fact has been written with empirical relation, then this come the energy separation has this from 20 into L plus half A to the power 2/3 MeV. That means the spacing not only depends on the values of L, the orbital quantum number, but the spacing is also dependent on the um, mass number, sorry, atomic number of the nuclei. That is the number of proton of the nucleus. Now, if we use this thing, that there is a splitting of energy level for a particular L value, and these values are J equal to L plus half and J equal to L minus half, then each L value has twofold degeneration, or in other words, J value has twofold degeneration. Now in order to express these things, we put L values with number and L values with spectroscopic notation as used in the atomic physics classes. For L value 0, spectroscopic notation is S, for L value 1, P, for 2, D, for 3, F, for G, 4G, and for 5H, for GF, for 5H. Up to this, we need not the other numbers we needed. Now, next step would be for each level, for each alpha value, we have to consider the values of n and consider the values of L, and for each L value, we have to consider there will be degeneracy, and we have to consider the J value. This figure will help you to understand the concept. Consider first that we are taking alpha values to be 0. You can remember the equation of relating alpha value, alpha, n and L were given in the table. The same relation will be used here, but now for each L values we should assign 2 J values, and for each J value there will be 2J plus 1 number of nucleus. In this way we will proceed. In the course of calculation you will understand better. Say for example, we are taking alpha equals to 0. Then what values we had? We had for alpha equals to 0, n equals to 1 and L equals to 0. So we use it. For n equals to 1 we write 1, and for L equals to 0 we write S. So 1 is state. So what will be the J value? J value will be equals to L plus half and L minus half. That means 0 plus half and 0 minus half. And since half minus value for J, absolute value of J is not acceptable, so we are taking the only one value, J equal to plus half. So the state is denoted as 1 is half. And how much nucleon will be there? The number of nucleon will be 2J plus 1. So J equals to half. So number of nucleon will be 2. As it is, if you read the first stanza, first energy level corresponds to alpha equal to 0, so n equals to 1, L equal to 0. Then only J equal to half is present, which is denoted by 1 is half. Number of nucleons in this state is 2 into half plus 1, because half is the J value, 2J plus 1 equals to 2. So the one state which is non-degenerate state, because a single energy state is there, the number of neutron is 2 and cell closure is 2. So it gives the first magic number. Now we come to the second step. Second energy level. For second energy level, alpha equals to 1. For alpha equals to 1, n equals to 1 and L equals to 1. So it has a single value. It appears, if we do not consider the spin orbit coupling, then it is a non-degenerate state. Non-degenerate state because only one energy level is there. So n equals to 1 and L equals to 1. Now for L equals to 1, for L equals to 1 we write 1, for L equals to 1 we write P. So this is a 1P state. For L equals to 1, the J values should have 1 plus half and 1 minus half. So J values is 3 by 2 and half. Now we have calculated in a previous slide, I have shown you that J equal to L minus half value has greater energy value than J equal to L minus half. So J equal to 3 by 2 has energy value lower than J equal to half energy value, right? So now the number of nucleon is equal to for J equal to 3 by 2 is 4 and for J equal to half equal to 2. So the total number of nucleons in this energy cell 1p uh, doubly degenerate. This is a degenerate state because two energy levels are there. After spin orbit coupling, energy levels have been splitted. So so in this state, we will say that we see that the number of nucleons is 6. So the and previous number of nucleon is 2. So the cell closure is 8, which is the magic number. Now let us consider the third. For the third energy state, energy level alpha equals to 2, it has two L values for two sets of n and L values, because n and L are relation. For n equals to 2 and L equals to 0, we call 2s state. And for n equals to 1 and L equals to 2, we call 1D state. Now this 1D and 2s state has same energy theoretically, but if we consider the relativistic effect, as you know, A stage is spherically symmetric, but the other states are not so spherically symmetric. So if you consider the relativistic effect of the nucleon, then the energy levels of these two different. That's why it has been shown in the table. Now the 2s state is non-degenerate state because it has only single energy value, and its total angular momentum number is equal to J equal to half. And the 2D state, as L equals to 2, as L equals to 2, it has two values. 2 plus half is equal to 5 by 2 and 2 plus half equal to 3 by 2. So these states are denoted by 1D 3 by 2 and 1D 5 by 2. Now 1D 5 by 2 has lower energy and 1D 3 by 2 has higher energy, and we put this in the accordingly. So 1D state has been splitted due to the spin orbit coupling, and two levels 1D 3 by 2 and 2D 1D 5 by 2. 1D 3 by 2 goes up and 1D 5 by 2 goes down. So the total number of nucleons for 3 by 2 is 4, for half equals to 2, for 5 by 2 equals to 6. So total number of nucleon is 10 here, and previous value is 12 here, and the previous value of the cell closure is 8. So total cell closure is 20, which is the magic number. Now up to this it is fine. It agrees well. It can also be produced with the previous model when we do not consider the spin orbit interaction. But when we consider spin orbit interaction, then the first three values are same. Now the different the other magic number will be produced as follows. Now consider the fourth energy level for alpha equals to 3. For alpha equals to 3, we have two sets of n and L values. One is n equals to 2, L equals to 1, so it is 2p state, and n equals to 1 and L equals to 3, we always give 1 f state. So there are two states. One is 2p state and other is 2f state. As usual, these two states are separated due to the relativistic effect. Now the 1f state, f value for f L equals to 3. So for L equals to 3, we have J values 7 by 2 and 5 by 2. But 1f7 by 2 has lower energy and 1f5 by 2 higher energy. So these two states are splitted. So 1f5 by 2 goes up and 1f7 by 2 goes down. And the same way for L equals to 1, 2p state, J value is half and 3 by 2. So 2p half goes up and 2p 3 by 2 goes down. Now you can see that the 1s level has been splitted more. The splitting of 1s level to 1s level, 1s 5 by 2, 1s level is larger than the splitting of 2p half and p levels. Because in the expression for L values, in expression for separation from energy, there comes L. Splitting has is increased as go up higher values of L. If you consider the 1f 7 by 2 energy level, this energy level has been lowered so much that it forms a separate level, and it contains 8 number of electrons because 8 number of nucleons, because there are 7 by j value is 7 by 2 and the number of nucleons will be 2j plus 1. 2 into 7 by 2 plus 1 will be 8, and the cell closure will be 28, which is a magic number. So now you see that this 28 comes entirely because of the spin orbit coupling. Because due to the spin orbit coupling, the energy level, previous energy level, has been split so much that the lowest energy 1f7 by 2 comes down very low in such a way that it forms a separate energy level. So magic number 28 is obtained. Now the rest of the electrons in this level, rest of the nucleons in this levels are p half, 2p half, 1f5 by 2 and 2p3 by 2, and these values are 2, 6, 4, totaling so 12. So 28 plus 12, 40, which is a semi-magic number. This number was there in the previous table when we did not consider the spin orbit coupling. Right? Now the next energy level, I think this is fairly simple to you. Still I am repeating it because so that you can grasp it more easily. And the final state, alpha equals to 4. For alpha equals to 4, we have 3 sets of energy values. Right? We have 3 sets of, up to this there are 2 sets of energy values. Now there are 3 sets of energy values. For n equal to 3, L equal to 0, so this is a 3s state. For n equal to 2 and L equal to, so this is a 2d state. For n equals to 1, L equal to 4, so this is a 1g state. So 3s state, 2d state, 1g state, these states are same energy. These energy values were same, but due to the relativistic effect, their energy is separated. Now for each L values, there will be different J values, so energy will be splitted. As usual, 3s state will be non-degenerate, so it will not split up. 2d value will be split up into 2d 3 by 2 and 2d 5 by 2. 1g value will be split up 1g 7 by 2 and 1g 9 by 2. Now here also in the previous case, 1g 9 by 2 will be the energy value of 1g 9 will be lowered so much that it will form a separate state, and it has a number of nucleon. Since its value j value is 9 by 2, the number of nucleon will be 10. Now, totaling the total cell closure 40 plus 10 equals to 50, which is a magic number. Right? Now the rest of the nucleon in this cell you can calculate. 3s half 2, 2d 3 by 2 4, 2d 5 by 2 6, and 1d 7 with 8. So 2 6 2 4 6 6 6 12 8 20, and the previous cell closure 50. So it gives you 70, which is a semi magic number. But that this has not been shown, but you can see that this is the same magic number that we have obtained in the previous table, where we did not consider the spin orbit coupling term. Now the last magic number for the protons, 82. How it will be obtained? Now you have up to 70 you have calculated. Now the next energy level will be L alpha equals to 5. So for alpha equals to 5, we have the relation for, I am calculating it. for alpha and I leave it as an exercise to you. For alpha equals to 5, we have for alpha equals to, we have the relation is alpha equals to 2n plus l minus 2. So we can take n values to be say 3, n value equal to 3. So we take n equals to 3, then n will be 3, and then l will be equals to 4. L will be equals to 6 minus 2, 4. So L value will be equals to 1. Right? For n equals to 2, L value will be equals to 3. L value will be equals to 3. And for n equals to 1, which is the lowest value, L value will be equals to 5. L value will be equals to 5. So the states, as you can see, the states will be 3p1, then for 3 value, then 2x, the states will be 3p, 2x, and 1h. So it will, three levels will be there, 3 L values will be there. L values will be 3p, 2f, and 1h. 3p, 2f, and 1h. Now the 1h level, for h L equal to 5, the j values will be equal to 5 minus half equal to 9 by 2 and 5 plus 11 by 2. So 1h11 by 2, the energy level of 1h11 by 2 will be lowered in such a way that it forms a separate level, and it has number of nucleons. Since J value is 11 by 2, the number of nucleon will be 12. And the previous cell closure was 70, and if you add up 12 with 70, it gives you 82, which is a magic number. Now you can calculate, as I leave it as a task for you. You can calculate it for the, you can calculate how many nucleon are left in this level, and consider the next level, that means alpha equals to 6, so that you can produce the next magic number 126, which is the magic number for neutron only, because 126 number of proton inside the nucleus you will not find it. That up to that level you have science has not reached yet. So you can calculate the next magic number 126, and in calculating, in the course of calculating, you can also calculate the same magic numbers, that the numbers you have obtained in the previous table. The next slide show you how these energy levels have been splitted, and how the number of nucleons have been calculated. I am just going very quickly with it. You can follow it on your own. The first have been stated before. The second energy level corresponds to alpha equals to 1. So L equals to 1, L equals to 1. Then there are two levels given by J equals to 3 by 2 and J equals to half, which are denoted by 1p 3 by 2 and 1p half respectively. Number of nucleons in that state is 2 into 3 by 2 plus 1 equal to 4 for J equal to 3 by 2, and 2 for J equal to half, making total number of nucleons 6 in this level. Therefore, 2d cell to second cell closure occurs at nucleon number 8, which is a magic number. And third energy level corresponds to alpha equals to 2. So is n equals to 1, L equals to 2, and n equal to 2, L equal to 0. Then for L equal to 2, there are two levels given by J equal to 5 by 2 and J equal to 3 by 2, which are denoted by 1d 5 by 2 and 1d 3 by 2 respectively. Other state 2s half is non-degenerate. Number of nucleus in this state are 6 plus 4 plus 2 equal to 12. Therefore, third cell closure occurs at nucleon number 20, which is a magic number. And in a similar way, the other energy levels, fourth energy levels and fifth energy levels have been calculated, and the last magic number, has been left as an exercise for you. You do it on your own and show me the result. And in the course of your um, study, if you find any difficulty in following, one difficulty may be this notation SPDS, this notation. Actually, if you feel this difficulty, then this reveals that you are lacking in the knowledge of atomic physics, which you have taught in your undergraduate courses. In your undergraduate courses, these notations SPDS have been done, and the spin orbit coupling was also there. So, in a sense, this is nothing new. What tools have been used here is basically the rules of quantum mechanics, and with the use of Schrodinger equation and several restrictions, we find that indeed the spin orbit coupling and the consideration of harmonic oscillator potential and spin orbit coupling. With a spin orbit coupling term, the nucleons inside a nucleus indeed form a self structure. In a similar way, the electrons in the atoms form inert gas self structure. Now, next we have to consider the success and failure of the cell model. Since it's a triumph itself, it has a triumph that it can explain magic number, which are natural magic number, show nicely such that we have a solid ground in proving this, solid ground in considering the cell model. Next, we have to consider the success and failure of cell model. This is a success, but there are some limitations of the cell model. We will discuss it in the next class. For the time being, I am leaving it here today. I will again advise you to do the calculation and do the homework that I have given in the video. Thank you, everybody.